So 60 kilometer per hour is 16.67 meters per second. So the distance d will be v squared divided by 2a. This is from the kinematics equation, v final square, v0 square plus 2a delta s, which is the distance. Okay, rearrange it. And you get 16.67 squared divided by 2 times 7.09. So you have 19.6 meters. Not bad. Notice that the velocity is squared, right? So braking distance actually goes up by the square of your velocity. So if you're going twice the speed, your braking distance is 4 times greater. Keep that in mind the next time you speed. Alright, so that's the stopping distance. Are we skidding the tires? Well, to do that, we need to find the slip point. Let's hope I have enough space here. The front axle slip point, front tires. First, we estimate the normal force, right? The normal force for the static load for the front is 1,500 times 9.8 gravity, right? Times 0.6, and this is the weight distribution. 0.6 is the weight distribution for the front, and so we have a normal force of 8829 newtons. Therefore, the maximum force before slipping, F max, is 8829 times the coefficient between the tire and the road. Doesn't say there, but this is the coefficient, tire friction coefficient. Pretty high, okay? Which is 7060 Newton. So this is the maximum it can take for the front. Let's see, with the braking torque of 1245, what are we looking at? So the currently applied force is this, right? This is the front. This is the front. So we need to compare this to the braking force. I'll get out of the way soon. Okay. So braking force for the front only will be 2 times 1245 divided by 0.3, which is the tire radius. So the front braking force is actually 8,300 Newton. What does that tell you? It slips, right? Maybe slips by a little bit, but tire slip. So that's the front. Let's do one for the rear. Rear tire slip. Let's see. So the normal force, you understand what I mean by normal force, right? So this is the ground. the normal force is this. It's the force from the ground supporting the weight. So the normal force for static load is 1500 times 9.8 times 0.4. Again, this is the rear weight distribution. 40% on the rear. Okay, so there's the normal force. Therefore, the max braking force before slip maxed out at 58.86 multiplied by 0.8 is 4709 Newton. Again, this is the tire friction coefficient. What about our current braking force? So braking force on the rear only is this component, right? So 2 times 350 divided by 0.3. That comes up to 2333 Newton. No tire slip. This is the maximum before slip. This is our braking force. Okay? Stopping distance, deceleration. Now, because of these things, even though you try to size, you see that we already tried to size that the front can take, will apply more force significantly than the rear, but still there might be slipping. That's why we do a proportional valve. The proportional valve do 2 things. One is the delay. The other one is the dividing the hydraulics differently. So we assume the same. We assume the same master cylinder pressure here throughout the circuit, meaning the front and the rear is under the same hydraulics. In reality, it's not. Mika, do you have one from the injector pulse? This is the ignition that you sent. The injector pulse is before that.
The one that I sent is which one, sir?
Is ignition timing. Do you have one from injector pulse?
Not that pulse one.
You have one? Okay. Any questions? So the simple model kind of helps you understand the mechanics of it. You press on the pedal, multiplied by the lever, multiplied by the brake booster. That's the equivalent amount of, I mean, that's quite a bit, right? That's 240 kilograms on the push rod. You got this pressure in the system, the front braking torque calculated at the caliper, the rear braking torque calculated on the rear. That gives us the braking force on the vehicle, right? 2 times that, 2 times the front, 2 times the rear. You got 10,000 Newton of stopping force, 1,500 kilogram of mass, end up with 7.009 meters per second square. The stopping distance is 19.6. And here we're just checking for the slip. Okay? So I think that's enough for the day. So next week, let's do a quiz on injector pulse width and ignition timing. The week after, let's do today's material, which is engine cooling and brake system analysis. This is the 10th week, is it? Or 11th? 10. Okay. So we'll spend some time there. And then I'll have something on hybrid and batteries in EVs. And that should sum up the semester. For the final exam, I think it's better to have an oral exam. Yes, just the 3 of us. It's easier, it's faster. I think it's more accurate. So I'll create study guides from the recording. I think there are study guides from LM already. Yeah. So it's just based on that study guide. We'll just discuss it.
For the quiz, are we allowed cheat sheet or?
Yeah, I'll give you all the formulas. I don't believe in memorization.
I got a random question for you. Do you think aeroplane engineering is harder than automotive or mechanical engineering?
Aerospace engineering is. I think it's not.
It's like the next level of engineering.
Yeah. You deal with a lot of fluid flow.
So,
Yeah, because it's air, right? Aerodynamics is a tough subject. It's that tough. I know many people who dropped out.
Because my dad, before I decided to go, before I decided I like cars and stuff, I actually want to be a pilot, right?
Yeah.
But my dad told me you should learn or study aerospace engineering.
But pilots, I don't think pilots study aerospace engineering.
That's a whole different.
It's different, but my dad told me don't be a pilot, just be the engineer for the plane.
I mean, he just wants you home more often.
Even to be a mechanic for airplane is very easy, quote unquote easy.
As a mechanic.
As a mechanic,
Yeah.
so, and it's very well paid, like very well paid job. Because a lot of people don't know about mechanic. When you get mechanics, it's only car mechanic.
Yeah.
But there's like boat mechanic, there's airplane mechanic, there's like heavy duty mechanics. All of this mechanic is like in great demand, like so much.
I imagine. Yeah.
A lot of people don't, and it's like just basic stuff, and you get hired like instantly.
Mm. Yeah, I think if you have hands-on skills, it's not a bad idea.
Yeah. And my teacher who taught me about engine, my very first teacher, he left school to be airplane mechanic, and he said like it's so well paid.
I don't have the hands, that's the thing. I'm a better astronomer than astronaut. That's what it is. I'm the theory guy. But I love practical things. So I'm a theory guy who tries to do some practical things. But I'm not, I don't have the hands, right? My son, he has the hands-on skill pretty good. He hates theoretical stuff. So yeah, something like that might be suitable for someone who loves practical hands-on stuff and who hates a lot of theory. I mean, you still have to take quite a bit of theory, but not that much. For example, you'll be doing this stuff. This is more like a vocational school.
Advanced vocational.
Yeah, a bit, but you know, vocational schools, you still learn some theory, but a very simplified model. So SGU, even though we offer a bachelor degree, I think our classes are mostly like D3, like a diploma, like polytechnic style theory, because we don't get that deep. If you go to the state universities like University of Indonesia, ITB, then you'll learn like the real science. Painful. The lecturers are also very much theoretical.
I think when we went to China, we met the first time we went to China. Me and my friend Edward. There was students from Brawijaya and from Malang University, and a couple of those. And their mechatronic and our mechatronic is quite a bit different in terms of how deep they go in.
Yeah.
It's not like
they're more scientific.
Yeah, they're more into modeling and
Yeah,
all that. So they do a lot more calculation. It's more hands-on, I guess. And all their workshop and everything, they do everything in deep. Like we do workshop, but they do it like fully. They have like a full-on karting team, and they spend their whole night with the teacher and everything, like just sitting and building cars. They do the modeling of the car and all that. Actually, one of the team went to Qatar. They won the Shell.
The Formula
something.
SAE.
I forgot.
Campus competition thing.
Yeah, it's a campus something, and they won that. And then they went to Qatar. Qatar or Kuwait, I forgot.
Qatar.
Yeah, Qatar.
Oh, cool.
Yeah, they're like very in deep in everything. I was like, we go in, but like we just like touch on everything. But when they go in, they're just like fully on everything.
Yeah.
It's,
Cool.
Yeah.
All right. Are all of you doing double degree in Germany?
No.
China. Only me and Mika. Yes.
You're going? You're not going to Germany?
I am.
I'm going.
You've been to China, right?
Yeah, I'm going to China.